First, congruent, figures having identical shape and size. Now, if we're talking about congruency in a triangle, or in a set of triangles rather, angles and side lengths are identical. Okay, that's how you have a congruent set of triangles. You have three sides that are all the same length, and the angles are all the same measure. Corresponding is in the same relative position. So if we talk about two triangles, and they're arranged to where they're in the same, pointing the same direction, this vertex corresponds to that vertex. Those correspond. Likewise, this side would correspond to that side. And then this vertex, this vertex would correspond to that vertex. This side would correspond to that side, and so on. So they're in the same position between the two shapes. Okay, so what we have, two triangles are congruent if and only if the vertices can be matched in such a way that the measures of the angles and the sides are equal. So between ABC and JKL, angle A would be the same as angle J. Angle B would be the same as angle K. C would be the same as L. And then AB would be the same as JK. BC would be the same as KL. And JL and AC would have to be the same. Now, in ABC and XYZ, it's very obvious to see that they're not congruent because they're different sizes to start with, and they have to be the same shape and the same size. But even with ABC and JKL, if I didn't mark these, which I did mark them, so that shows that they're congruent. If I just showed you those two triangles and there were no marks on them, you couldn't say they were congruent without doing the measurements to make sure the angles all matched and the sides were all the same length. Like even if they look the same shape and size, they might be slightly off. Yeah. So you have to, they either have to be marked or measured, which I just showed you. This is another way. I do the multi-loop thing like that, but you may also see tick marks in the single loop. They're both equivalent to show that the angles are the same. The sides, though, there's just tick marks. We can't really do anything else with the sides. Okay, so we're going to identify all of the corresponding and congruent parts. So when I look at this, angle A is the same as angle J. Angle B is congruent to angle K. Angle C is congruent to angle L. AB is congruent to JK. BC is congruent to KL. And AC is congruent to JL. Okay. And then we have that triangle ABC is congruent to triangle JKL. And order matters. Okay. The order of the triangle listing tells me, when I have this congruent statement, that A is congruent to J, and B is congruent to K, and C is congruent to L. So the order is really important. Triangle ABC is congruent to triangle JKL. It is not congruent to LKJ because A and L aren't the same. Does that make sense? So we have to be really careful with that. The order matters. So we don't have to have the picture of the triangles. If I have triangle DEF is congruent to triangle RST, and the order matters, I know that angle D is congruent to angle R, angle E is congruent to angle S. Let me do that a different color. And angle F is congruent to angle T. So that tells me the angles. So I can write those down. And then for the sides, I take the first two letters. So DE is congruent to RS. Last two letters. EF is congruent to ST. And then first and last. DF is congruent to RT. So I don't have to have the actual triangles drawn out to be able to tell what's congruent to what if I have the names of the triangles. Or if you want, you can draw the triangles and label them and everything and do it that way if it's more visual for you. This is what I was talking about. You can draw a picture. If ABC is congruent to PQR, draw ABC and PQR, and then you can say, oh, B and Q are in the same spot. Yay, okay, so angle B is congruent to angle Q. Did you have to draw the picture? No. But if it helps you, draw it. If you don't need it, just say, okay, B and Q, they're in the same place. So it's up to you. They're both correct. Now we get to our practice. Triangle ABC is congruent to triangle UVW. So what I'm going to do is I'm going to highlight A and U are the same. B and V are the same. And C and W are the same. So what I have now is U is 12, V is 49, and W is 119. What's angle C? Well, W is blue, C is blue, so C is the same as W. Does that make sense? Yeah?
Is there an example where it would be a different color?
Yeah, if I said what is the measure of angle A, then I would say, okay, well, A is green, U is green, so A would be 12 degrees, and B would be 49. Would be exactly the same. Now, you might have an example where I say angle A is 2x plus 5, and angle U is, like 17 degrees or something, and then you'd solve for x, but they're congruent, so they're the same. Does that make sense? Here, let me...
So you would say like 2x plus 5 equals 17.
Yeah, so let's say if angle A was, we'll keep it 12 for you. We'll say angle A was 2x plus 4. Find x. Well, angle A is the same as angle U, so that means 2x plus 4 would be equal to 12. And then we'd solve it from there. Subtract 4, and you get 2x equals 8, and then divide by 2, so x equals 4. Is that okay? If these two triangles are congruent, we're going to find the value of x. So we have to figure out where x is in position over here, because the triangles are rotated. X is the hypotenuse of this triangle. So it's 17. So x equals 17. Sometimes you get this situation where you have triangles combined. And in that case, sometimes it's easier just to use the letters. But if you want the triangles, take them apart. So I have J and M, and then I'm going to draw the other triangle. And L is on the long pointy part, K is on the top, and J like that. So it can help to do that. LK is congruent to JN. LK, JN. Angle JMN, M is the angle right here. So J is the angle there. So that's going to be a J in the middle. And to figure out the order, I have JMN. So I went last, first, second. So I go last, first, second. So LJK. Does that make sense? Okay, so as I was saying a minute ago, every triangle has 6 parts. The 3 sides, 3 angles, 6 parts. So if we have 2 triangles, each has 6 parts. In order to show that the 2 triangles are congruent, we have to have 3 of the 6 parts from each triangle matching. And they have to be certain 3 of the 6 parts. It can't just be any 3. It has to be specific 3. And the first one of them is side, side, side. If you have 3 sides on this triangle and 3 sides on that triangle and they match, then the angles have to match as well, because the length of the sides dictates the openings of the angles. So side, side, side means that all 3 sides pair off and are congruent. Then the triangles, the whole triangles are congruent. So that's the first one. That's kind of the easiest one. So, this side matches this side matches that side matches that. And if they were rotated, it wouldn't matter.
Can the rule be flipped? Like if all the angles are the same, does that mean all the sides?
No. Here's how, that's a good question though, but like here's why not angle, angle, angle. Here, I'll make it A. Angle, angle, angle. So let me draw you a triangle. Okay. Now if I take that triangle and I make a copy of it, that's congruent. I made a copy of it. These angles are the same as those angles. And if I expand the triangle to a scale, these angles are the same as these angles, but the sides are not congruent anymore. So I might have angle, angle, angle. But the side lengths are no longer the same. So the sides can regulate the angles because they kind of like box them in, but the angles can't regulate the sides, because you can have, when you think about like an equilateral triangle, 60, 60, 60, but you can have an equilateral triangle that's like microscopic, or you could have an equilateral triangle that would take up the size of a whole building, or anything in between, or even bigger. So it doesn't work. Now we have angle, side, angle. If 2 angles and the included side, so this is the side in between the 2 angles, are congruent to the 2 angles in the side of the other triangle. So that's angle, side, angle. And that's what we have right here. We have angle and then a side and then the angle. And they have to go in that order. It has to be angle, side, angle. So as you travel around the triangle, like around the perimeter of the triangle, you would hit an angle, then you'd hit the side, and then you'd hit the other angle. And then when you went to the other triangle, they would be in the same order. Okay. So that's the second one. And then you have side, angle, side, which is just like angle, side, angle, but reverse. Yeah, you have 2 sides and the angle between them. So I have this side is congruent to that side, and then I have an angle and then a side. So again, as you travel across around the triangle, you can go clockwise or counterclockwise, it doesn't matter. I'm going to get side, angle, side, and they're going to match. And the postulate names tell us the order they have to be in. So right now we have, just to recap, we have side, 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 angle, side, angle, and side, angle, side. Okay. We do not, nor will we ever have, angle, side, side. And this is not because we don't want cussing in geometry class, which we don't, but that's not why. Angle, side, side doesn't work because I can have, let's say I have a a 30-degree angle and another 30-degree angle. Okay, so those are going to match. And then I have a side length of 5 and a side length of 5. And then I have a side length of 10 and a side length of 10. But see how this angle and that angle aren't going to match? That's going to change the length of this side. This side over here is going to be much shorter than this side over here to try to meet that 10. So that's why angle side side doesn't work, because the angle side angle works because this angle over here restricts that third side. But angle side side doesn't work because there's no restricting from this angle. So depending on what direction this side is going, that tells me how long this side is going to have to be to make it fit. So that's why it doesn't work. So just so you can remember, there's no ASAs in geometry. So you'll know never to do it because you can't have that. Okay, so here's our example. Find the value of x that makes them congruent, and then state the postulate that made them congruent. Okay, so here I have two triangles, and then for them to be congruent, I need this x over here to match this 9, so x has to be 9. And then I look to see what I have. I have side, angle, and then a shared side. So side, side, angle, side. Like that. So far okay? Okay, so stating the postulate that makes them congruent, I have side, angle, side, side, angle, side. So, and you have to check both triangles. Don't just look at one triangle and then say, okay, that's good, side, angle, side. Because if this one had been marked like that instead of like this, you would have had to say not congruent. Because they wouldn't have matched. So you want to check, you always need to check both triangles to make sure they actually do match before you say, because it is possible that you could have not congruent. Here, this one's not marked, but if they're sharing a side, if they share a side, it's the same length, you know, that makes sense. So we have 3 sides, side, 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 side. So we're good. And then no, because basically it's a flip or rotation, and that's okay. The triangles don't have to be like facing the same direction.
Those are connected, but the ones above aren't.
Yeah. And then here we have 19, 28, and 35. I have 1935, so this has to be 28, and that would be side, side, side. But if you want to be creative, we have another one. These are vertical angles, which means they're congruent, so I could say side, angle, side as well. So I would actually, because of vertical angles, have 2 ways to say these triangles were congruent. And sometimes you do have more than one way, depending on what information you have.
Because I mean, we obviously know that.
No, vertical angles are the only angles that don't have to be marked. Yeah, so if you get that X, we have a theorem that tells us vertical angles are congruent, so those don't have to be marked. Any other kind of angles, like over here, like these are marked, we'd have to have another marking somewhere to be able to use any other angles. Does that make sense? Okay. So your homework is in the packet. One through 5, which is supplemental 9. I guess I could stop the recording.